Hello, here we go again. We are back with stoichiometry. Remember, stoichiometry is what? Is the quantitative, mix up the I and the A there. Quantitative, yeah, that's right. Quantitative comparison or relationship between two different things in a chemical reaction, okay? The quantitative relationship between two different things. It could be product with a reactant, reactant with a product, product to a product, reactant to a reactant. So we're comparing the relationship between two different things. So if you have a reaction, reaction goes A plus B gives you C plus D, for example. Okay? So you have that relation, and the number in front, what we learned last class or in the previous video, is that the numbers in front of them represents the number of moles. So 3 moles of this plus 2 moles of that plus 5 moles of this equals 5 moles of that plus 1 mole of D, for example. These are our mole ratios, okay? So the numbers in front tell you how many moles, not how many grams. All right? So this is what I mean. I'm going to use a more specific example here. H2 plus O2 gives you H2O. Okay? And we have to balance that. And the balance equation is 2 H's plus 1 O give you 2 H2O. But the mass is not 2 grams. Okay? This is 2 moles. What's the mass of 2 hydrogens? That's 2. The mass of H2 is 2 times 2 here, so the total mass here is 4 grams. Okay? 2 moles of H2. 1 mole of H2 is 2 grams. That's how I got that 4 grams for that one. Okay? 1 mole of O2, the mass of O2 is 32 grams. Because 16 plus 16. Okay? And the mass of water here, water, remember, H2 is 2, 2, and then 16, so that is 20, right? 20 times 2 is, wait, something's not right. H is 1 and 1, so 18 times 2 is 36 grams. Okay, so you notice the law of conservation of mass is conserved because 32 plus 4 here is equal to 36. Alright? But the equation, if you cover that up, the equation only shows you mole, 2 moles, not 4 grams. 1 mole of oxygen gives you 2 moles of water. So remember, the equation gives you a mole relationship. Okay? Equation gives you the mole relationship. And you have to know that, you have to understand that, and it's not complicated. It's just very basic that you have to know. It gives you the mole relationship. The grams, what do you have to do? The grams, you have to get the periodic table and multiply it by the mass of that hydrogen. Okay? And so, today's lesson, I'm going to go over the, so we have, let's use that equation again. H2 plus O2 gives you H2O. Alright, and there's the 2 there, there's 2 there, there's the 1 there. Okay, today we're going to go over something we call mass to mole, or mole to mass. Mole to mass. That means mass of substance, like mass of H2, and we're going to go to mole of H2O. We're going to see the relationship between that, or mole of H2, we want to go to mass of O2. We want to see how much of that do we need. Okay? We had a similar example with this when we did the s'mores. Remember I gave you one question about 30 grams of chocolate plus 40 grams of marshmallows. How many s'mores can you make? You first need to find out how many pieces of each, and then you figure out how many s'mores you can make. So that was, we did something similar to this. But before we do this, I'm going to ask you to remember one pattern here, okay? The pattern is grams, mole, mole, grams, lowercase g. grams, mole, mole, grams. So if you follow this pattern, grams, mole, mole, grams. So this is grams of substance A. You have to go to mole of that substance first. And then you can switch over to mole of substance B, and then you can find the mass of substance B. Okay? Just memorize this right now. Grams, mole, mole, grams. Grams, mole, mole, grams. Grams, mole, mole, grams. What's always in the middle? Mole to mole. Okay? Mole to mole, we've already done that. Remember last time? Mole to mole, we start with mole A, whatever that mole of that substance is. Then we put mole A down here, that substance, and then we want the one that we want to get to, mole B. And we get the mole to mole, we get this relationship from the equation. Okay? We get this number, these numbers in the front, these mole, number of moles from the equation. When it's mole over mole, look at the equation. Then when it's grams and mole, we've done that in the past. We've converted grams to mole a lot already. So that's the general idea here. So if you could turn your page to this page, the second page, you should have number 1 through 11 done already. Okay, we continue moving on to mole to mass here. Mole mass and mass mole conversions, 2 conversion factors. So we need a mass mole conversion factor and a mole mole conversion factor, and you'll see that. You hear a lot of the stuff. Maybe some of it don't make sense to you now, but it should eventually do. Okay, so the conversion factor used to convert between the mass and mole is called a mass and mole is a here. Let's look at some of these words. Molar mass. Molar mass. This value is obtained from the periodic table. Is that periodic table? Yeah, periodic table. For a compound, the masses of the atoms must be added to obtain the mass of the compound. Yeah, you have to add up all the elements to get the mass of a compound. That's what that's saying. Molar mass is the mass of 1 mole of that element or compound. The coefficient in the balance equation only tells the ratio of two of the substances. So molar mass is used whenever the question involves mass or grams. Mole mass and mass mole problems are always involve 2 conversion factors, the mole ratio and molar mass. The order they're used depending on the given. Is that one of the things? Depending on the problem. Depending on the problem. Yes. Okay. So draw a schematic map of stoichiometry problem. Label the conversion factors used. Here's a stoichiometry map. You're going to go with grams of A, 2 mole of A, then mole. Then you can use the conversion factor, mole, and switch to mole B, and you go to grams of B. Okay? And here's the mole map. The mole map tells you from grams to A, then you need to get the grams, then you need to get grams on the bottom, mole on top. Get the molar mass. So you're going to use the molar mass here. The mass of whatever A is. Okay? Mole to mole, where the arrow to switch, you'll use the mole ratio. This is from the equation. Okay? You look at a balanced equation, get the number of moles. That's your mole ratio. And then mole to grams here, again, we want mole B on the bottom now, because we want to get to grams of B on top. And this is molar mass again. So, at most, you're going to eventually do all 3 steps, molar mass, mole ratio, molar mass. But today, we're either going to do molar mass, mole ratio, or mole ratio, molar mass. One end or the other. Okay, just 3 steps here. Alright, this part is fairly simple there. Make sure you get the mass of all this and get into the habit. I want you to write 2 mole ratios for this. So aluminum, you either write 1 mole of aluminum is whatever the mass of aluminum is on the periodic table. And the mass of aluminum is 26.9. So I'll say 26.98. So 26.98, whatever, grams of aluminum. Or you flip it over, 26.98 grams of aluminum is 1 mole of aluminum. Like that. You flip it over, you write 1, you flip it over, because you don't know which part you'll use it. If it's at the beginning, you want grams at the front, grams at the bottom, sorry. And if you're trying to find grams at the end, you use the grams on top. So depending on the question, you'll use the appropriate one. Okay? And so you have to write really small here, because the space is tiny. So make sure you go through, do all that. Let me do a more difficult one. Here, H2. So 1 mole of H2 is 2 grams of H2, because each hydrogen is 1. Or I can flip it around, or 2 grams of H2 is 1 mole of H2. Okay? So do that for all these. It's really nice and cool. Yeah, it is. Okay, and so let me do a couple more problems before the video gets too long here. 14. 14. Write that down. Grams, mole, mole, grams. Get that straight. Okay? So, first of all, here are the steps. We follow the same steps that I showed you last time. How many grams of ammonia? Box what you're trying to find. Grams of ammonia. So we want to find grams of NH3. Ammonia is NH3. Okay? We will produce from 10 moles of nitrogen gas. So we start with 10 moles of nitrogen gas. We find a nice pen here. There you go. 10 moles of nitrogen gas. So 10 moles N2. Okay. So if we start with mole of N2 and we want to go to NH3, we want to get to grams of NH3 at the end. What do we have to go after moles of N2? So that means if we start with mole, then that's the first mole right there. So the order is moles, moles, grams. So it's mole. We have to go to a mole in the middle first. Mole in the middle. You ever played that game? Well, you're playing it right here. Mole of NH3 is in the middle. And so that's your grid. Okay? So it's mole, mole, gram. We want to go from from mole of one thing to mole of something. I'm going to start that over. If you want to go from mole of one thing to the grams of something else, mole of A to grams of B, you have to go to mole of B first. So it's mole, mole, grams. You always follow that order. Okay? If you remember this, this will be so easy for you. In other case, grams, mole, mole, grams, grams, mole, mole, grams, grams, mole, grams. Say it enough where it'll haunt you at night. That's great. Okay? So 10 moles here. So then you copy the units down. Mole of N2 down here. Then mole of NH3 down here. Remember, we copy this whatever unit, just the unit, okay, not the numbers, bring it down. Copy the unit here, bring it down to the next one. Pretty simple, okay? Now, fill in the numbers. Now, that's something you have to think about and something you have to remember. Because filling in this number, you remember it once, you remember it for the rest of your life. Yeah. So, mole and mole. What did we say to use with mole and mole? So remember, mole over mole, get it from the equation. Mole and mole, mole of N2. Just look at what number is in front of N2. Nothing there, so it's a 1. NH3, there's a 2 there. That's the mole ratio. Okay? Good. And then mole of NH3, grams and mole. Remember, grams over mole, always 1 mole. Okay? Grams and mole, always 1 mole. What's the mass of 1 mole of NH3? Nitrogen is 14, and then hydrogen is 1, hydrogen is 1, hydrogen is 1, plus 14 here, then we have 17. 17 grams. And you put an equal sign, and that solves the problem, ladies and gentlemen. How beautiful is that? Okay? So, these units cancel out, and the last thing you have left is grams of NH3, which is exactly what you're looking for. You multiply the top and divide by the bottom. Voila. I'll do one more problem to keep this video under 2 hours long. Okay? Let's do one more problem. Cool. Let's do number 19. Number 19 is cool. Looks coolest. Alright, here it is. How many moles of calcium nitrate? So we're dealing with calcium nitrate, which is this last one right here. So we're trying to find how many moles. So then we're trying to find moles to make 600 grams of silver nitrate. So if you have silver nitrate, which is this, we're dealing with those two. Okay. So what do we start with? We start with grams. Remember, the order is grams, mole. You can write this down every time if you want. Grams, mole, mole, grams. We start with grams. So let's put that at the beginning. 679.5 grams of AgNO3. And what are we trying to go to? Moles of calcium nitrate. So then that will be the last thing. Moles of calcium, CaNO3, 2. So we don't need that last grams. Okay? That's there. And so some of you might think, like, why did I skip the middle mole? Right? Yeah. The reason is you can't go to mole of calcium nitrate until you get to mole of silver nitrate. Remember, the second one is the mole of the first thing. Okay? It's grams of the first thing, mole of the first thing, mole of A, gram A, mole A, then gram B, then mole B, gram B. So the first mole is the mole of whatever that first thing is, if it's not already mole. If it's grams, you've got to change it to moles first. Okay, this is a better color here. So I do that, and what do I do next? I copy the unit down to the next one. Copy grams of AgNO3, go down here. See, that's there. I bring it down. All right. It's like a finding something. One of those little kids show where I ask you a question, and I pause, and you answer it, and I'm going to compliment. Okay. What goes down to the bottom one next? Correct. Correct. Mole of AgNO3. Correct. Good job. Mama would be really proud of you. Okay, so back to this. Mole and grams. What's the deal with mole and grams? It's always what? 1 mole. And where do I get the grams? Yes, correct. I add them all the masses together. The mass of Ag is 108. This is a big number, so I'll round it. Mass of Ag is 108. N is 14. 3 oxygen, 16, 16, 16 is 48. Add them together, that's 0, 2, 6, 160. Cool, 160 grams. Okay. And so mole to mole, though, where do I get this number, mole to mole? That's the mole ratio. Good. I heard you say that. So what is the mole ratio? Look at the equation. 2 agno. So put 2 in front of the agno. CaNO3, 2. That's 1. Multiply the top. Divide by the bottom. Voila. That's your answer. Okay? So, confusing at first, yes. Difficult at first, maybe. But if you do it over and over and over again, you should get it. Okay? So, please don't let the mass, the whatever, all these things, the confusing things that, don't let all these things that look confusing stop you from trying. Okay? You've got to try to do this. You've got to practice over and over again. So you're to finish 15 through 18. And then it's going to review you number 20 to 24. It's a mixture of a couple of things here. It's a mixture of a couple of things. All right. So, but if you remember to follow my path of grams, mole, grams, you should always get these right, or at least set them up right. And so, like number 20 here, what mass of aluminum is needed? 20 moles of aluminum oxide. So we start from mole of aluminum needed, mass of aluminum. So then the mass, if you're looking for it, it's going to be at the end. If you're looking for that mass, it's going to be the last mass. If you're going to look at for the mole, then it'll be the last mole. Okay. So mass of aluminum you need to start with, and whatever you start with, you put it. It's one of the two at the beginning. All right. So we start with 20 moles of aluminum oxide, Al2O3. So we don't need that first G. Okay, you can write it all out and then cross them out afterwards. All right, and so here's your grid. Okay, this space is too small for that marker. So mole of that, mole of Al2O3. Then we switch over to mole of aluminum. Then mole of aluminum oxide, mole of aluminum, grams of aluminum. the last two, the grams and mole last two, remember they have to have the same. They have to have the same thing. So as aluminum and aluminum, okay. And so, oh crap, it's over 20 minutes. Okay, sorry guys, you gotta finish this problem, and yeah, finish all the way through 24.